Hello and good day. This is teacher Onin Guzman, and welcome back to our class. Our topic for today is distance formula. In the next section, you will be assessing your knowledge and skills of the different mathematical concepts previously learned, particularly in the performing mathematical operations. This knowledge and skills will help you to understand the distance formula and its application to real-life situations. For us to have a better understanding on distance formula, so let us consider the triangle NGD. So the line segment GD is considered as the height of the triangle NGD. So I can write this one as A, okay, is equal to the difference of y sub 2 minus y sub 1 because this is the difference of y sub 2 and y sub 1. So y sub 2 minus y sub 1. On the other hand, the line segment ND is the base of the triangle. So base is equal to the difference of x sub 2 minus x sub 1. And remember that I can have here the right triangle. So therefore, I can determine the value of the hypotenuse. By the way, the line segment NG is the hypotenuse of the triangle NGD. Now, let us recall that in the Pythagorean theorem, so hypotenuse squared is equal to the sum of the squares of the two legs. So that is c squared is equal to a squared plus b squared. If we will substitute the value of a, which is y sub 2 minus y sub 1 squared plus substitute the value of b, which is equal to x sub 2 minus x sub 1 and squared. So this is the value of your hypotenuse c squared. However, I want to find out the value of my hypotenuse c. So I'll take the square root of both sides of the equation. So c is equal to the square root of y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. So this is considered as the length of the line segment NG. So line segment NG is the same as the square root of y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. So take note that the line segment NG is the distance between the 2 points NG. Okay? I can rearrange this one also as x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared using the commutative property of addition. So this is equal to your hypotenuse. But hypotenuse is the same as the line segment NG. And take note that the distance between the line segment NG is the same as, okay, the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So therefore, we can say that the distance in symbol d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. To summarize, the distance formula between any two points in the coordinate plane can be solved using the distance formula, whether they are aligned vertically or horizontally. Now, let us consider the points N. We have the coordinate 0, 6 as well as point T at 8, 0. So we will use now the distance between the points N and D. So using the formula, D is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. But before that, let's identify the x sub 1, x sub 2, as well as y sub 1 and y sub 2. So we have the point N, and it has the coordinates 0, 6. So we will let this one as our x sub 1 comma y sub 1. So therefore, x sub 1 is equal to 0, y sub 1 is equal to 6. Also, the D has the coordinates of 8, comma 0. So our x sub 2 is equal to 8, while our y sub 2 is equal to 0. Using these values now, we will substitute this in our formula. Take note that x sub 2 is equal to 8 minus 0 squared for our x sub 1 plus y sub 2 is equal to 0 minus the value of y sub 1 is equal to 6 squared. And take the square root of this expression. So we have 8 minus 0 is equal to 8 squared plus negative 6 squared. And take the square root. So this is square root of 64 plus 36. So simplifying it further, so we have the square root of 100. So the distance is equal to 10. So let's have another example using the distance formula. So determine the distance between the points A and B. So again, we will determine the coordinates of points A and B. So A has the coordinates of negative 4, comma 6. So this is our x sub 1, comma y sub 1. So x sub 1 is equal to negative 4, y sub 1 is equal to 6. Next, B has the coordinates of 3, comma 8. So we will use this as our x sub 2, comma y sub 2. So it follows that x sub 2 is equal to 3 and y sub 2 is equal to 8. Remember that the distance formula is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and take the square root. So let's substitute the given values. So we have the square root of 3 minus negative 4 squared plus 8 minus 6 squared. So we have the square root of 3 minus negative 4 is equal to 7 squared plus 2 squared. Simplifying it further, so we have 49 plus 4. So we have square root of 53. So therefore, the distance between A and B is equal to square root of 53. So let's move on to our third problem. Determine the distance between C and E. Again, let's find out the coordinates of C and E respectively. So C has the coordinates of 5, comma 7. So we will use this one as our x sub 1, comma y sub 1. So it follows that x sub 1 is equal to 5 and y sub 1 is equal to 7. Next, E has the coordinates of 5, comma 2. So we will use this as our x sub 2, y sub 2. So using the distance formula, we have the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and take the square root. So we will simply plug in the values. So we have the square root of our x sub 2 is 5 minus 5 squared plus y sub 2 is equal to 2 minus 7 squared. So let's simplify. So we have the square root of 0 squared plus negative 5 squared. So we have the square root of 0 squared is equal to 0 plus negative 5 squared is 25. So therefore, the distance is equal to pi. So however, you can easily determine the distance between the points C and E by simply counting the number of units vertically. So I have 1, 2, 3, 4, and 5. So we can use this one only if this is horizontally distance or vertical distance. Let us consider problem number 4. On the coordinate plane, a map is drawn showing the different health centers of Binakayan Municipality. Each unit is equivalent to 4 kilometers on the coordinate plane. If the coordinate of Lorega Health Center is 26 and Pulog Health Center is 10.8. What is the shortest distance between these two health centers? Recall that the shortest distance between 2 points is a straight line, provided that there is no hindrance along the way between Lorega and Pulog. Therefore, we can determine the shortest distance using our distance formula. Now, let L as the coordinates of Lorega Health Center at 26. So, if we will use this one as our x sub 1, comma y sub 1. So, our x sub 1 is equal to 2, y sub 1 is equal to 6. Next, for our pulog, we have 10, 8. If we will use this one as our x sub 2, y sub 2, then x sub 2 is equal to 10, y sub 2 is equal to 8. So using our formula for the distance formula, then we can simply substitute. So we have x sub 2 is equal to 10 minus 2 squared plus 8 minus 6. So simplifying it further, so don't forget to write 2 here. So simplifying it further, so we have 8 squared plus 2 squared. So this will give us the square root of 64 plus 4. So this is equal to square root of 68. So this is approximately 8.25. However, 1 unit is equal to 4 kilometers. So therefore, we have 8.25 times 4. So this is equal to 33. So therefore, the shortest distance between the two health centers is 33 kilometers. So let us consider problem number 5. A flower garden is mapped on a grid with the nursery as the point of origin. If the entrance of the garden is located at 6, negative 10, what is the distance between the nursery and the entrance of the garden? If we will analyze the problem, it seems that we have only one coordinated point, and that is at 6, negative 10. However, if we will analyze it further, we have the word origin. Remember that the coordinates of the origin is actually at 0, 0. So this is our x sub 1, comma, y sub 1. Next, so we can use the coordinates of 6, negative 10 as our x sub 2 and y sub 2. So we can now use the distance formula of the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay? And simply substitute the given values. So we have 6 minus 0 squared plus the value of y sub 2 is equal to negative 10 minus 0 squared. So we have the square root of 6 minus 0 is 6 squared plus negative 10 squared. Simplifying it further, so we have the square root of 36 plus 100. Or this is equal to the square root of 136. Simplifying it further, so we have 2 square root of 34. So therefore, the distance between the nursery and the entrance of the garden is 2 square root of 34 units. So to summarize our discussion, so this distance formula is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So this is the distance or the shortest distance between the 2 points. Again, this is teacher Onen Guzman and thank you. Do not forget to subscribe to my channel to be notified on my new videos.